Okay, good day. I'm going to deal with circuit analysis. Before I proceed any further, can you please subscribe to the channel, like the video, and share the content with your peers? Okay. Firstly, for you to deal with circuit analysis, there are some basic rules that you need to follow. You need to understand, for example, Ohm's law. You need to understand Kirchoffs laws. So during the session, I will keep on referring to these kind of laws and explain what each means. So the method that I'm going to use on this circuit, it's called a nodal analysis. Okay, so Kirchhoff's current law says, okay, so I'm going to do some justice and try to explain what is a node. When we talk about a node, we are talking about a pathway in a circuit where it separates two circuit elements or more. For example, this point at VA, it's called a node because it's a pathway where the current passes in between, for example, this resistor R3, resistor R1 and R2. So VB is also a node. This one is also a node. This one, it's called our reference node, of which is the ground. It is V0, 0 volts. Okay. Now, since you have an idea what is a node, later on I'm going to explain what is a mesh. I think on a different video. Now, what can you do to find all the currents that flows through each resistor and finding VA and VB? Okay. Firstly, you need to know that voltage or the current moves from a high potential to a low potential. That means our current will move in this direction from this voltage. Okay, so even here our current will go to that direction. So clearly, if we have a current coming from this direction to that direction, when they reach VA, they're gonna go down. Okay, yes. So now Kirchhoff's current law says the sum of the currents that flows into and out of the node adds up to 0. Okay, or alternatively you can say the current that goes into, okay. Now since we know that the sum of the currents that enters node A must equal in value the sum of the currents leaving a node A, we are going to verify this hopefully at the end of this video. Okay, now let's make an equation of node A. The current, this is current I1 that passes through R1, and the current that goes into, I'm going to make them positive, so I'm going to have current I1 plus, okay, no, current I2 leaves, so it's going to become negative, minus current I2 plus current I3, which will equal to 0. Okay, but now I know the value of current I3 because it's 5 amperes. So I have I1 minus I2. Since I know that this one is 5, I can just say plus 5 equal to 0. Now, what is I1? So current I1, let me write this with a different pen. Current I1 is equals to 70 minus VA over 10 ohms. Okay, This is current I1. Now current I2 is equals to VA over 5 ohms. Okay, now I'm going to replace I1 and I2 into that equation and see what we have. So I1, we have 70 minus VA. I'm sorry, let me change to a different pen. Divided by 10. Minus VA over 5 plus 5, which equals to 0. Let's get rid of the fraction, then I'm going to multiply the entire thing by 10. So here I'll be having 70 minus VA minus 2 VA, 10 plus 5 is plus 50, which equals to 0. Here I'm going to have negative 3, so I'm going to put like terms on the same point. Okay, let me shift this thing. Alright, now putting like terms on the same side, I'm going to have 70 plus 50, which is my 120, which is equals to 3 VA. Now if I divide by 3 both sides, VA is equals to 40 volts. Okay, now I have my VA, I can look for my VB. So let's see, how can we solve for VB? I'm going to make an equation here. Now I3 is equals to the voltage here multiplied by, I is equals to V over R, so it's equals to the voltage here divided by this resistor. So the voltage here, since the direction of the current goes from this side to that side, VB should be greater than VA. Okay, so when I'm looking for I3, I'm going to say VB I3 is equals to VB minus VA divided by 6. Now I already know my size of I3. Now this is 5, which is equals to VB, our unknown, minus 40 divided by 6. If I multiply both sides, I'm going to have 6 times 5 is 30, is equals to VB minus 40. Now if I transpose 40 to the other side, it will become positive. Okay, so that means my VB will equal to 70 volts. Now since I know VB and I know VA, I can find my current I2. So I2 is equals to VA over R2, which is 5. This will be 8 amperes because this is 40 here. 40 divided by 5 will equals to 8 amperes. My I1, I can also find my I1. Okay, so I1 is 70. I1 is, so here I have my, it's I1 equals to 70 minus VA, which is 40, divided by the resistor of I1, which is 10. So 70 minus 40, it's 30, divided by 10. This will cancel that. My I1 is equals to 3 amperes. I have my I1 as this, I have my I2 as 8, my I3 is given. Okay, so if we go back to the circuit, if we go back to the circuit, we have, I'm going to write to this color, we have 5, we have 3, so 5 plus 3, they will add up to, okay, let us look on the given circuit again and analyze it. We are again going to use a nodal analysis to solve this. This is a little bit complex compared to the previous circuit that we did.